Yeah, you can proceed, Alex. I think he's on mute.
So Alex, are you asking me?
Yeah, I think Alex is on mute.
Okay.
Yeah.
Oh, hi.
Yeah. You can give a context of the question. You can just.
Okay. So I'll first share the doc link to you guys to the chat. You may come and free to add it. So basically, this is a question that occurs may like the last round of the interview. I have 4 rounds in total, and at this round, I was facing a engineer manager. Well, he just left this one sentence of the questions here. So I was like, okay, I have to clarify a lot of stuff before I start to, presenting the whole design in question. So the first thing I did was I first clarified the requirements of this server. So as it described in a sentence, we have 2 functions in total, like main functions. The first one is to store the content. The second one is to get the content. But it all depends how you like dominate the whole workflow. You can, from this point, I think we have various way how to like go through the questions. And I was doing just like, I may write the workflow of how our service been worked, like from the endpoint to the database. So, but yesterday I forgot his name. Someone like approached me and showed me his solution. It's pretty like mine. Maybe I can just like copy his solution into the doc. Oh, so yeah, I was just writing similar things to the coding pad or doc during the interview, like this, and I explained to him how the workflow like goes. Yeah, and this one should be okay. And then yeah, at this point, I think before I write the workflow here, I don't know. It's my first time interviewing a system design question, so I'm not sure if I should clarify a QPS or workload here at this point, but I didn't do that. So I'm not sure if there's it's a minus point minus. And then after I demoed the workflow to him, he like questioned me some details, like how the logic part works. For example, this put servers and get servers. What's the details of logic in put servers and get servers? So, and basically, I answered with I don't know, it's right or wrong, but I replied if I will design it, I will maybe use MVC pattern to like accept the RESTful API and to accept the HTTP request from the endpoint and then to the service layer and to the repository layer and then back to there. So that's my that's how I demoed the logic of the main service in our workflow. And after that, okay, yeah, after that, he questioned me details about the cache service here. Like what tags that I use for implement the cache and what the data structure looks like in a cache. So I just said I use Redis for cache, and the data structure is key value pair. That's my shallow knowledge about the Redis, and then after all of this stuff, it probably took me 40 minutes, I think. So it's just have few more minutes left, and he asked some follow-up questions. I don't know exactly how many follow-up questions he had, but for me, for the last few more minutes, I was only got 2 follow-up questions, and it's all about one thing. But I don't think it's proper way to show you guys, because I want to leave the follow-up questions later after we discuss the main things, the main stuff upon. So probably we can discuss the follow-up later. It depends on how we will design this server. So yeah, and another thing I forgot is when I demoed the workflow of our service, he asked me and about the caches, the details of the caches. He asked me how I can deal with like how I can scale up the system to like distribute the system, and do I ever heard about CDN before and how it works? But I don't think I answered it in a proper way. So maybe we can discuss about that later. Yeah, that's basically the whole thing of my interview was going on. So yeah, you guys have any thoughts or ideas?
So since I would say like this is kind of, it seems like not a storage system, but it's kind of like you need to architect the put service and the get service. That's what I realized out of this whole question. So one thing I can suggest here is since they are saying like Amazon.com, correct? And it's a kind of like having a millions of products and millions of users data available, right? So here, one thing I can propose, we can separate.
You put your advice and add information on the doc if you have a link.
Yeah, I can add it later. If you can share the same document in that, and then I can put my thoughts here. But here is my thoughts. That's how my company works at this moment, because I work for like around 100 billion events a day and thousands of users, more than 2,000 users, and we have like 100K users active at a time. So the way we have designed the system, we need to separate out the DB, like your read store and the write store should be separate out. And all of them are go to the middleman as a Kafka. So whenever, let's say you're trying to get, whenever you, let's say you're putting a service, like that means you are like inserting a record or updating a record, correct, in the database. So in that case, you just go to the Redis and dump the data and just forget it. It's going to work automatically. So from the Redis, we connect to the Kafka, and Kafka puts the data in Elasticsearch. So that communication data reached to the Elasticsearch, it's kind of like millisecond, very fraction of second we update in Elasticsearch. But whenever you get it, you just go to the Elasticsearch and get the data. And on top of that, we added caching mechanism. We are using Elastic Cache and Elastic data store as our record. So all the data set we have is in like a JSON format at this moment. We have for financial data only, we persist in RDBMS because we need to maintain all the transaction and other stuff. So that one thing I can propose, we can separate out the DB for write and the read. That's how the whole microservice architecture works. So whenever the microservice comes in picture, they always use some pattern called event sourcing. They're using most of the time, and there are few more patterns in the microservice, but we are using only handful of them. We are still trying to learn and adapt it. In traditional microservice world, if you think like let's say you design a microservice using a Spring MVC or the Spring Boot, so that way you just have a one data store where you can insert and update and delete happening through the one data store. But in this case, you just dump it to the Redis and you just forget it. And then things flow till the Elasticsearch. And the replication happen between, like sync between Redis and Elasticsearch. It's very, very manual, it's kind of eventual consistent. So within a fraction of second, the data get updated there. If anybody's have any thoughts about it.
So how does the data go from Redis to Elasticsearch? Like how Kafka is listening on it on Redis?
Yeah. Yes, right. So Kafka is kind of like listening to the Redis, and then data goes to the Elasticsearch. So we have connector between Kafka and Elasticsearch. So there is a component called Kafka Connect. I think Kafka Connect we are using. So Kafka Connect is one component which we are using heavily for most of the ingestion part in any of the data store. We are ingesting in S3, Salesforce, in multiple data store. So they have almost a handful of connector is free from Confluent. So that's what we are using at this moment.
So can you talk about how you store these products or whatever records that you are getting into Redis? Like what would be the key and what would be the value and what are the topics that you use to propagate these products into Kafka? Like in some details.
So one thing I can suggest, like if you think about whenever we persist the data, we definitely have some unique ID, right? So if you think about the product catalog, most of the catalog is having a some QR code, or we are saying like SKU ID, correct? SKU number. So that's what we can use as a primary key. SKU number is a very unique. The same way, if you think about the books is having a unique ISBN number. That is a kind of like SKU number. So that's something we can use as a primary key. And that's something used in a data store as a primary key.
Right.
Another thing, if you think about the topic, so for the product catalog, I would say we can use just one topic, because product catalog can have multiple attributes, correct? Like from SKU to like your seller ID and whatever the inventory that they have. So they mostly inventory is kind of like second level, but the product catalog can have only the product related information. So I would say we can just use one topic for the whole product catalog and just dump it to the Redis, and it goes till your data persistence layer.
So why you choose Kafka to transfer data? Why not just normal workers listening onto Redis, like pulling from Redis?
Sorry, guys, just to sorry to interrupt, but can we just focus on the question on hand? I understand this is very interesting topics, but I think there are people who are just waiting to get workflow on this.
No, but he's talking about his suggestion only, right? So that's why.
Yeah.
No, I think his design could be translated into this specific requirements, but we need to understand like how those components fit together and whether it's a valid choice or not. Whether should we remove some components or maybe we should add different components, something like that.
Yeah, that's what we are thinking. So this is my suggestion, but if you guys have another thoughts, you can add it as well.
I think the focus of this question is to see how he actually designed the schema. And in the workflow, he said that he actually using load balancer and other stuff like caching, but without discussing the request volume or data capacity, he can't go for it, right? Because it doesn't make any sense why he's been using those load balancer and caching things. And another thing is, if the system, I think noise is coming from someone's. So can you please mute? So if the system needs to store multiple images with the content, so how is he going to store those URL? So if he wants to answer these questions, he also have to probably discuss what kind of data store he is going to use, whether he is going to put it in the SQL or no SQL. So that is one kind of discussion that he can lead from that place, I believe. Here, another thing that came into my mind is that he only shows how to store and retrieve the information. And it's true that the interviewer actually asked him to do so. But in a real world system, when you are designing some system, you actually have to make it flexible so that other components can come, other components can be integrated easily. For example, after updating or after creating this content, in notification can be thrown, right? So he should have some kind of mechanism in place, so from where this system can be extended. So yeah, I think the question can be lead in many directions. So yeah, and that's my thought.
Hello.
Yeah,
Hello?
Go ahead.
Is that Alex, like, who was suggesting to use Kafka? I think that sort of architecture perfectly works here. So that might be even the expected solution also, because because the speed at which the producer is producing might be different from the consumer. The sink, which is CDN, might be able to ingest. So even if the CDN is down, those things can stay in Kafka for a while before getting retried. So just my thought. I mean, I think that might be the solution, because the different components are involved, and their state, I mean, they're being up or down, is independent of each other. Like using this Kafka queue, I think we could accomplish that.
But why Kafka? Like normal workers or a normal queue could have also been used, right? I mean, I don't understand like Kafka, the specific reason for that.
So you're saying I don't know the nitty-gritties of Kafka versus other queue products, but some sort of queue is needed here, because for the reason, like I said, like one point could be that the CDN could be down, right? CDN or the Elasticsearch could be down. In that case, somebody needs to retry, and they need some sort of a buffer to stay somewhere, right? So that buffer is the queue. I mean, but again, like I said, like I don't know the nitty-gritties of Kafka versus, but Alex or whosoever who proposed it can actually.
Just a quick question. I mean, whoever is mentioning that Kafka, like since they have already used it in their system, maybe they have more internal like details. Maybe they could share some more details regarding those internals, so that I mean, obviously, these are all, rather than we making some assumptions. If somebody could who have already implemented this could speak about this, then it would be much more helpful.
So this is Alpesh. I propose the Kafka idea basically. So the Kafka at this moment we are using, the main reason is basically a distributed message broker basically, correct? So there is no downtime. There is a one server is down, second is already up, and it's become like claim as a leader, and your system up and running. The second part is like it's highly available. You won't have even downtime at all. And as we said, like we are using a CDN to persist all the images. In that case, it's definitely needed, because when you put it, you need to update your continuously CDN, correct? Otherwise, your CDN is having a like still data and your application is having a something else. So let's say I am in other part of the world. I am just typing amazon.in, correct? So I don't want to load my US product catalog in the system on my browser basically. So whenever I type on the browser like amazon.in, my request goes to the close to the India CDN server. And then it picks up all the India related images or product catalog and loading to my browser. That's how the things work. So let's say you are typing in somewhere in Germany website, right? So in that case, your request goes to Germany and then your image is loading. So your all the static data, whatever the fonts, images, and other part, whatever static data we have on the website, correct? It's always reside inside close to your country CDN. That's in AWS, they are saying like edge node or something on the availability zone they have on the edge node. So edge node is close to your country. So India, one part we have in Mumbai, another part we have somewhere else. Singapore, we have Singapore CDN. So your all the static data lives close to the country, so that you won't have, when you load to the website, it won't take a much time. And CDN is basically kind of like caching a static data. So it's not updating that frequently, but every few hours you need to update your catalog, correct? Because your produce, your I would say seller, let's say in this case, they just say put and get service, correct? That means it includes your consumer as well as provider. Provider means your seller, correct? So seller keep on updating the catalog. So you keep on updating your CDN as and when required. And it's a kind of like real-time streaming. It's not kind of like you run the batch every few hours, because your all your CDN is continuously updated through some streaming platform, and that is the reason I choose Kafka. Is that answer the question, or we have more?
Yeah. So, I mean, if you use single topic, how do you parallelize things? Obviously, Kafka is used for whenever we have high scale, right? So in case we have a bunch of products coming in, bunch of product streams. So how are you parallelizing it in your system?
So basically, the Kafka Connect server, as I said, right? So Kafka Connect server, what is the responsibility? Like it updates your caching, like Elasticsearch or Elastic Cache. It update your data store where your CDN is located, right? So in Kafka Connect server, you have a mechanism to parallelize the process. Otherwise, you need to maintain the parallel processing in your application code. What it's a kind of like you are developing your own Kafka Connect server. But the Kafka Connect server having all the features available, like parallel processing, how many tasks you want to run, what is your like buffer time, and what is your buffer size. So it spill over the data to your persistent store based on the two factor. One is buffer time, second is buffer size. So let's say you are saying, okay, I need to speed out my data as soon as 5 minutes happen, or my buffer becomes say 1 MB or 5 MB or 50 MB. So as soon as either one of the benchmark hits, it spit out the data to your target system. So that something is very much configurable. You don't need to always go and change it. You decide based on your business need, and then you can just configure the data.
Hello.
Yeah.
For capacity planning, right? I think now that we kind of like agreed upon some approach for capacity planning, because like Kafka is being used as a buffer. So what kind of questions what kind of things should be taken into consideration? I mean, two things that come into my mind is size of each message, like the size of the key and the size of the value and the velocity at which they're coming, and the duration for which they need to be stored. But I don't have like much experience with like using Kafka as like this kind of a message queue, but someone can throw some light on like how to do like capacity planning like more in depth. Yeah.
So in that case, like we in our infrastructure, we are managing a 4 server, but I worked in a PayPal as well. They have like 100 server in Kafka because they are heavy processing data, right? So it's based on the business need. We can configure Kafka Connect server, Kafka server, not Kafka Connect, Kafka server. So the way it works, whenever you create the topic in one of the broker, that's called a leader. In Kafka architecture, there is a leader node. So you have one node as a leader. So when you create a one topic, so it requires two I think one parameter, partition size. Yes, partition size and replication factor, two things we need basically, right? So replication, as we know, like you have multiple copies of data, correct? Like how many nodes we have, that many replicas we can create. And the second part is partition key. So you split your message in multiple partition. All of them are having a same key. All of them are having a same key. So let's say you have how many replica count and how many partition based on your split your message. So that many copies you have. So at the consumer side, it takes out the data automatically, and the Kafka API support most of the stuff. Kafka API support your, like, because whenever you consume the message, you need to go back and have all partition available, which is having a same key, and then you persist the data. So Kafka APIs provide internally all the mechanism, and Kafka Connect server is already have all the implementation available. You don't need to change anything, just configuration. So in that case, you have like replication as well as your partition key. That way you can manage your velocity. Like let's say your data is coming very fast, you can increase the server, increase your partition. And let's say you have static data once in a day, you just need 2 or 3 copy of data in either one of the server, and then based on that you can decide.
Okay. Okay, but I was under the impression that if different microservices are consuming or like are pushing messages to Kafka, so I think how big the Kafka RAM or like the disk should be, and they are in some sense like dependent on the size of the message, like size of the message as in the size of the object value here, key value. We're talking about key value pairs, right?
Yeah.
So what are the questions to like ask the consumer, the producer, the data producer here, so that the Kafka is never down?
Yeah, right. So basically in that case, there are configuration parameters. I don't remember. I'm still doing some course, certification course on
Sure, that's okay. Yeah.
So basically, the way it works is you have some message size you can configure, like this big message size I'm expecting. So based on the like sample data set, we can decide, okay, your product catalog, one message can have this many attributes, like 100 attributes, because as Amazon.com, when you load the page, you have tons of attributes, correct? So one catalog, one product can have multiple attributes. Right now we are streaming a data on the Salesforce, one table we have 600 column, but we are happily like streaming the data continuously. There is no downtime at all. So based on that configuration parameter on the Kafka, we can manage the product catalog.
Okay, thank you.
Guys, one basic question. I joined the call 10 minutes late. So we are discussing about how to design a product catalog on Amazon.com, right?
It's kind of like one subset of this use case, what Alex mentioned, but we drill down to this direction, like how to manage like high throughput or high volume of data. So I proposed the architecture, the screen you see.
Yeah, thanks. But sorry to interrupt you, but what did we start with initially? Just like in one line or two line?
Okay, so the one liner I would say, we are designing Amazon.com, and we suppose a put service and the get service. So you can get any put service and any get service, like customer get service, customer put service. We are thinking about product catalog because that is heavy throughput, correct? So that's how we drilled out with this direction.
Okay, thank you. I appreciate it.
Hey, Alpesh, I have a question. Thanks for the answer. But you said that you just, in the case of put service, you will just write to the Redis and then Kafka will be listening on the Redis. Won't there be a case of data loss in this case? In case the cache
data loss won't happen in Kafka.
No, not in Kafka. If the cache crashes before the Kafka listen to the data.
Listen to the Kafka. You mean to say at the consumer side, right?
Yes.
Okay.
So I said that the Redis node crashes before it is inserted, before the data is inserted to the Kafka.
Okay. That's something I need to research.
So we actually discussed this
that
part yesterday. So what happens is before writing it to the Redis, like you can configure the Redis cluster in such a way that it will write the actual data to write ahead log, and then it will write it to the RAM, so that when server crashes and reboots, it will reconstruct the data using the snapshots and the write ahead logs.
Oh yeah, we discussed that, correct? We need to, if the crash, we need to start from the top, the whole write log, and we get all the data in
Right.
memory.
I mean, it depends upon the use case of the application. If
Mhm.
you are fine with latencies, then that's how you need to go. But
Right.
Yeah, but we have to configure, but the snapshot is configured for every n seconds that we'll provide, right?
Yeah, those are all configuration details.
Yeah.
Right.
Okay.
And I think even Redis might have like replication in the sense that if one node crashes, the other node might be like continuous.
Yeah, I mean, again, it's
Yeah.
if you configure it as a distributed cluster and replication enabled, yeah, that's true. Yeah.
Yeah,
Yeah,
I think
right.
that's the whole point of like using Redis instead of like just using like a hash map or something. So,
Yeah. Right.
Thank you.
And why do we need Redis between, can't the producers directly, write it to the Kafka so that we can eliminate one intermediary layer?
That's something because we need some persistent store where we can say we just write the data. Because when you write to the Kafka, what if the Kafka is not available? So that is the reason we put one middleman where your Kafka is becomes a consumer for that particular like caching. It's a kind of like caching layer you put it. So you just dump the data in Redis and you forget it. And then you move ahead with the next task.
No, but the Kafka itself is highly available distributed system, right? So if Kafka is not available, I mean, there is a scope even for Redis to not be available, right? I mean, downtime is possible in either of the scenarios. But
Right.
I'm trying to understand what is the advantage that we are gaining by using an additional Redis between the producer and the Kafka.
Okay. That's something I can research and tell you. Why do you need a Redis?
Cool. I mean, yeah, obviously, since you...
I'm just list down all the questions, whatever we are discussing, so that I can find out the right answer.
Sure. Since you are already using the system, I mean, I'm pretty sure there might be some reasoning why they designed it, but I'm just curious to understand what is the reasoning.
Right.
And just one more thing around that the Redis part. So you are using Redis like kind of a temporary storage, and it's not like permanent stuff, correct?
No.
I mean,
yeah, right. That's correct.
Okay. And like none of the read requests will ever go to that Redis. I mean, to fetch the data. I mean,
yes.
It's just okay.
And the another part on the consumer side, how does it manage? Like Kafka, whenever you write some consumer, let's say there are multiple ways to consume, correct? Like either you can design your own application or you can design some tool which can listen from the Kafka. So most of the tools, and when you write a program, we need to make sure that, so whenever you consume the data from Kafka, correct? We need to inform Kafka, okay, I completed till this level. Let's say you read the Kafka topic data messages till the 100 offset, correct? And then next time when you talk to the Kafka saying, okay, give me the data 100 onwards, so that Kafka always know where you stopped last time. And for that, we need to manage some attribute. It's called a group ID in Kafka. So based on the group ID, Kafka manage somewhere in their database internally, saying, okay, if this group ID comes again, I'm gonna give the data from this offset onwards. And whenever we consume again, at the end, let's say you update your CDN basically, correct? In the Kafka in this case. So when we update the CDN, we get the 200 from CDN. And then we are saying, okay, go back and update Kafka now. I read till 200 now. So that way, whenever like you restart your process, correct, you won't have any duplicate data.
So basically, it's a way to identify the consumer.
Yes, right. Which consumer? Because all the consumer is having a unique group ID.
Okay.
Yeah, so basically, Kafka maintains a commit offset topic.
Yes,
and whatever like consumer consumes the data, it adds that commit to the topic that okay, I have consumed that much amount of data, and the next data you have to read from that offset itself.
Yeah. Right.
So
and another, go ahead.
Can you guys give an example of like an end-to-end example of this put service using Kafka and everything? I just want to see how all the pieces are together.
Okay, so
let's
let me just design. Let me just draw the diagram, and I can start it with this group, so that we are all understand. Because that way, this way, like I cannot explain in this. Alex just write in a line, right? Instead, I can put some diagrams, so that way we are covered in all pages.
Sure.
So one thing to add.
Great.
Yeah, one
you
thing
can share screen. You can share screen.
Yeah, so you could potentially end up having duplicate messages in cases where the consumer sort of consumed in a consumer group, like from a topic partition, and then it crashed and it did not commit the object. So you could end up getting duplicate messages. It's the responsibility of the application to sort of, if you need if you need an idempotent behavior, then the application should take care of it. So consumer group is a Kafka functionality where you essentially sort of Kafka simplifies this part of how to load balance the multiple topic partitions that you're going to consume across n number of consumers that you have. So if one consumer crashes, if you have like n consumers, one consumer crashes, there'll be a rebalance that happens, and so now the whatever are up, they can sort of consume from wherever the last one stopped. Things like that.
So what is rebalance?
Rebalance is so the consumer group concept has a state machine where you start with a rebalance. What rebalance is in a Kafka cluster, whenever you have a consumer, you have set of consumers that are part of a consumer group, and they're consuming from a topic which has multiple partitions, right? There's a group coordinator on the broker side, which is assigned to this. Now, what happens is the group coordinator coordinates how all these consumers are going to agree what partitions they're going to consume from. Okay, and if you just look up online in the Kafka docs, they have a state machine on how this happens. So it starts with a rebalance. When there is no consumers and consumers enter into that consumer group, you have a rebalance that is sending a message to everybody, like a handshake, to say that each of these consumers, what topic partition are they interested in? Because no two consumers can consume from the same topic partition in a consumer group. The idea is a message won't be repeated across consumers in that consumer group.
It's a kind of like a changing a replication factor, right? Like when in Hadoop, we are doing the same thing. When you increase the replication factor, it's rebalance the load between multiple machines, basically. Yeah.
You could put it that way. Essentially, what rebalance does is, if you have new consumers come in, sort of rebalance it across them, or if you have consumers dying, then there's a rebalance.
Yeah, again rebalance, right? Increasing or decreasing, you always rebalance the data, right?
So what happens if we have more consumers than the amount of data that's coming in? So will we have idle consumers for a while?
So it goes by the partition here. If you have more consumers than the number of partitions available on a topic, those consumers will be idle.
Okay.
Right. But if you have less consumers than the number of topic partition, then a consumer can consume from multiple topic partition.
Got it. So it takes a range of partitions.
Correct.
Got it.
Right. And who was the answering on the Kafka side?
I think Vijay.
Okay, so Vijay, I wanted to know about the Kafka part. Like, how do we decide the partition and the replica count? Is there any algorithm or like formula which we can decide? Like, okay, my broker nodes is this much, and I need to decide this partition and partition size is this.
That depends on what level of durability you need. There is two factors that you tweak, right? You have in-sync replicas, that is the number of replicas. I mean, there's a couple of things. First thing is number of partitions you want. So Kafka is horizontally scalable, right? I mean, so you scale based on first topics, and then in a topic you can keep adding partitions if you to sort of load balance the size of each topic partition across the different brokers. And once you do that, for the produce, you have two other factors. So each partition will have in-sync replicas, and then there is also a min in-sync replica factor, which you sort of, when you send a produce request, you sort of say, do you want Axe from the min in-sync? Now, based on the durability, you get to decide, like, what is the min in-sync? Min in-sync is at least those many have to sort of acknowledge before the produce response can say that, hey, I committed your message. Then then there is this in-sync replica, which is usually greater than the min in-sync. Those are the ones that keep fetching the data from these replicas that they're trying to sync from, and they get up to date. But it's all about the durability, like, I mean, how you want, and the speed.
Okay.
So if we increase the partitions down the line, will the existing data rebalanced across those partitions, or how does it work?
Are you guys still there?
Hello.
Hello. Yeah. Yeah. Sorry, I was on mute. So what will happen is, I don't think it happens automatically. You'll have to run some scripts for that, for rebalancing the data across the newer partitions. One thing to note there is when you produce, you would typically use a hash key to sort of determine which partition you want to land into, right? So when you add more partitions or remove partitions, it'll affect your produce path sort of, and the consume. If you were having a path where these producers produce to this particular range of partitions, and the consumption happens for this particular range, and they behave some way. So you just need to note that there'll be an effect on that if you add or remove partitions.
Hello.
Yeah.
Hello. Let's say like you have 20 partitions, okay? And for whatever reason, 4 of them got destroyed and whatever, okay? Then rebalancing needs to happen, right? Okay. So I mean, because if you have used it in production, like I'm just curious, like is the rebalance process slow, or it just?
So when you say
no, secondary partitions will take over in case of when primary partitions fail.
No. So here's the clarification. When you say 4 partitions are gone, are those like the 4 Kafka partition? If the partitions are fully gone, then you just lose data. You can't rebuild it, right? So a topic partition is what I mean. A topic partition has replicas, and there is a leader. If all those replicas representing a partition goes, then you will have a data loss.
I see.
But I think we can configure these partitions in such a way that it definitely has a secondary partition which is continuously replicating the data, right?
That's why you have, I think the earlier question that came in is, what is the replication factor you set? If the primary sort of goes down, then Kafka will automatically, the Kafka controller will automatically elect a new leader for that particular, in the replica list. So every topic partition will have something called a replica list. And that replica list will be brokers that are equivalent to your replication factor. Whenever replicas go down, or at least the leader goes down, sort of there'll be a re-election and a new one will come.
I see. So does Kafka has like the leader election and everything natively, or should we use?
It has natively.
I see. So they send heartbeats to each other and
correct.
Elect the leader. Okay.
And they use Zookeeper for some of it to sort of store some state, which they're trying to get away. I think they have gotten away in the newer ones, but yeah.
I see. Okay.
Now let's get back to the original question for Alex. Otherwise, we are losing in Kafka. So Alex, you get an idea about this now, or you still have more questions?
Yeah, I'm listening you guys talking about Kafka a lot. Sorry, I don't have much experience with Kafka, so
I found one very good link, but I don't know how to post because I dialed from my mobile. I'm in office, but I am still searching on the Discord or channel because I have a lot of server.
Okay, so from my understanding, the Kafka are basically doing the partitions. So you're creating some partitions like numbers. You probably have 1,000 for group 1, and you have group 2, So then 0, 1, and 2. So then like this, right? Partitions like this.
Right.
And what? So you will have workers come to those partition. Worker 1 and worker 2. So in that way, they don't interrupt with each other when they work on the different groups. And when the incoming data comes to our server, so okay, well, the same workers will do the storing and get stuff. So there's one thing I want to clarify is about in our case, we are storing the content. I assume it's an object or something. So what is partitions values in our case here? Can anyone explain it?
No, can you repeat the question, Alex?
I mean, the partition, like what is the partition store in our case? We are going to get and store the content to our database. Before that, we go into Kafka. And what is the values being stored?
I'm not getting your question exactly. If someone can understand.
Question is, how do you partition your data? What is the partition key?
Oh, partition key is SKU ID, right? As I said, we can use a SKU ID because that is unique for each product, correct?
Okay. So can you maybe demo the workflow, like from user in and to the load balancer gateway and to Kafka and then to DB?
Yeah, so what I can do, Alex, I'm on office laptop. So what I can do, I can draw the diagram and I can paste it in our group. I just posted one channel, which is kind of like lean towards that architecture, which we discussed just now. And that way we can get in the right way. Actually, I can draw the diagram in somewhere on my personal laptop, and I can send it here after this call.
Sure.
Mostly.
So since there was key value pair, so can't we think in the direction of a Dynamo, like for the DB?
Dynamo is the best for key value pair. We have used a lot. We just need to decide the partition key and the sort key in better way. For persisting images, correct? I would say we can use Dynamo. So let's say we are storing somewhere the images, correct? The way we have done is in one of the architecture, like we just persist the image URL. We cannot persist in key value pair value as a whole image on the Dynamo. So we persist the ST URL as a part of value, and the keys are kind of like IRN. We are saying one unique ID which we are using. So that way you can have better. You just need to decide what is your partition key and what is your short key. So partition key is kind of like SKU ID, and other one is you can say sort key. We can use a seller ID, I guess. That is also one we can use, or other way around as well. We can use seller key as your key and a sort key as your SKU.
So
can we perform? Sorry, go ahead.
Yeah, go. I'm asking, the goal of this system is what? It should be highly available, or I mean, it can compromise on consistency, because if we use the Dynamo, you'll have to go for eventual consistency, right?
True.
Right.
So what is the goal of this system? Right? System should be highly available in this case. Then Dynamo makes sense.
They are saying Amazon.com, so that means highly available.
Yeah, I assumed like this because it's like a non-functional solution we have to clarify, because I think for the interview, how you design the system or how you present your solution will affect on what a level they are going to hire you or what position you go to. So I think that's quite important if you have like a scalable or system to present to them. Yeah.
So if we store this data into Dynamo, I mean, we can't query this data, right?
We can query. Why can't? I mean, we maintain preference list, right? Where we just like a consistent hashing, we make sure that these data.
No. I did not mean it by primary key. Let's say now I want to find the products by some product type or maybe by product rating. Like, there are several factors by which user could query the DB. So, but when we put this in NoSQL DB like a DynamoDB, we could either query by primary key, or there is some other key, right? Like
sort key.
Yeah, sort key, either that. But we can't. Basically, what I mean to say is we can't query based upon the actual body values.
Yeah. So basically, for that, probably Dynamo has a mechanism. They're saying like local index and the global index. They have two mechanisms. So for, let's say, when you design the Dynamo table, correct? First of all, you need to find out what are the access pattern you need, first of all. So that means like how many ways you're going to trying to access the data. That way you decide your partition key and the sort key. Okay. Now let's say in tomorrow you design the system, and after a few years or few months, somebody came and saying, okay, I want the data in this way, but you don't have sort key and partition key designed that way, right? So in that case, you can go for the global index. That is kind of like replica of your own table, whatever we have. That is a costly approach. Okay. And then in that global index, you can decide what index you want to search for. So that can be anything which is not part of your partition key and the sort key in your primary table.
Okay, so how are this global index mapped to the actual data in the DynamoDB?
So it's a kind of like what I would say, it's a duplicate of the data. Internal, it's duplicate of the data. But when you call a Dynamo API, you won't feel you are calling a different table. It's kind of like two data set, one with actual data and another with another index, which is a global index, we are saying.
Okay, so if I understand properly, so basically the Dynamo, some background process will go over the entire like data available, and then it will construct an index. So when we query this index will be pointing towards the actual object that's available in the DB. So it's like a pointer.
Right. It's a kind of pointer. You're right, actually.
Okay. Yeah, I guess, yeah, I believe these are some kind of like follow-ups that they could ask depending upon whichever solution that we choose. Yeah, so it's good to discuss those. Yeah.
So what other kind of DBs, like can we prefer SQL here? Doesn't make sense, right? Because we don't have any ACID compliance sort of stuff. Neither we are caring about the consistency, right? So NoSQL makes more sense at this point, isn't it?
It depends, I guess, because the creating index is definitely a costly operation, right? So, but if you have the data in the relation style, then like you could easily query for different parameters. I believe. I mean, it's easy to query different parameters in the same product catalog table, and also if you have sellers, you could decouple the data and you could establish several kind of relationships, and then using the joins, of course. So, but then once you have only NoSQL DB, I believe we are limited to query by either sort key or the primary key. And once if we want to have another query again, as somebody is suggesting, we need to again go through the entire data and create some new index. But if it is RDBMS, we could even do it without index. I mean, let's say there is maybe very rare cases, user might be querying in some field which is not widely used. But in those scenarios, RDBMS comes handy, right? Because we need not create index, but that operation might take some latency since we don't have index. But just for the sake of that operation, we need not create index. But if we go with DynamoDB, we can't do that operation at all in the first place without index. So there are both pros and cons depending upon DBs that you are choosing and depending upon the user behavior. So I guess we need to ask these questions ahead and, yeah, come up with appropriate steps.
And that's how this Dynamo table, before design, we need to find out the access pattern. So if you see the kind of like best practices to design a Dynamo table, correct? The first thing is find out access pattern,
right?
And then you can decide accordingly.
Right. I mean, let's say this is a product catalog, right? I mean, maybe tomorrow, if there is an extension to say within a category of products, you want to advance your search with, like product specifications. Let's say I want to buy a TV. Now I chose a TV category, and within the TV, I might be choosing, 30-inch TV, something like that. So if user keeps on adding these queries, then it's easy for us to query the RDBMS compared to a NoSQL DB.
Right.
So these are some. I do not have complete experience on the e-commerce side, but I believe these are some potential use cases that we could think of.
And secondly, your product can be present in multiple categories, right?
Yes.
So
that's correct.
There might be a case when you have to perform multiple complex joins, right? Which is again not good for SQL, right? So that also gives SQL, right? Or what is your thought?
True. So whichever solution we choose, right, we definitely have, that's what these discussions are about. There is no one solution which fits everything, right? So there are definitely pros versus cons. So I believe, what you mentioned is correct. Like definitely we use joins, there is a overhead involved and there is a latency hit, but maybe that is worth it because of the extensions that we could make down the line. So, but if we go with the Dynamo, then it's definitely faster. Like you could easily query it based upon primary key or sort key. But again, if you need to extend your search functionalities, then you end up creating so many indices on all the data. Basically, you might be creating a copy of several objects, which will increase the whole data footprint. So in RDBMS itself, if you are not interested, if there are heavy joins, you could even create and decouple the data and put the data together so that joins are not performed. So either you go for denormalization in the RDBMS or go for the DynamoDB with increase in the number of indices and all this stuff. So there are both trade-offs in both approaches.
Yeah, it depends on again, what do you say, the context in which they want to have, right?
Exactly. Yeah, I see this has some relations because it's not like some user is simply generating. I don't know. This is not like maybe let's say like consider I couldn't come up with proper example. Let's say there is some device which is generating some sensor data or maybe a car sensor. Then such data will not have many relationships. Then it makes sense to go with some NoSQL DB. But in this scenario, I see there are some relationships between products, users and the sellers and all this stuff. So that's what I think. I might be wrong. If anybody else had any other thoughts on this, they could share the details.
So this is only one such architecture, like we'll have to use Kafka. Without this, there is no alternative, right? The one.
Honestly, if you think of the system, right, it's more read-heavy system. I think, I'm a bit skeptical about Kafka in this architecture because if you are using Kafka just for the inserting the data into the DB, then I believe your reads are much more. I don't know, 100 times more. You might be getting 100 times more requests than this. Then I don't know what kind of system you will be using to handle this much of read traffic, because once you observe the e-commerce websites, any of the websites, we all just try to browse the websites and purchase the products. Those products are updated by some sellers or some third-party people. So I believe those people are definitely less in number compared to the buyers who are purchasing. So it might be 10:1 ratio or 100:1 ratio. So I don't know if we really need Kafka. Kafka is definitely a highly scalable solution. But
no, the Kafka is only for the writing. Actually, when we are reading, we use a Elasticsearch.
Right. I mean, what I meant to say is, do we really need Kafka, or maybe we could get away with some other simpler solutions, because obviously managing Kafka cluster is not straightforward, right? Unless you have experience. So introducing, unnecessary dependencies or unnecessary complexity into the system is also not a good idea. So
because we separate out two concerns, like writing things is different and reading is separate. So that is the reason we keep on updating CDNs using a Kafka route. When you're reading, you go to the Elasticsearch and get the data.
Right. So, since you are already using the system, how are the validations done? Like, let's say some seller inserts their product or book details or whatever it may be, depends on the application. So how do you validate the authenticity of this data? They might be entering some invalid details. Where is that performed?
Oh, you mean to say fraud kind of thing?
Not fraud. Maybe I'm seller and I might be, I don't know, maybe you have some, let's say your company had some kind of rules and regulations that I need to bound to, but I'm not following them. Maybe I'm inserting, I don't know, I'm selling something that I'm not supposed to sell.
Oh, that is a kind of compliance process. We need to add that.
Yeah.
The compliance process, definitely we need to add somewhere whenever you are ingesting a data. That something is definitely needed.
Right. There needs to be some kind of automation, and then obviously some kind of human intervention is needed at some places. But what I'm looking for is, where can we introduce this automated way of filtering the, I don't know, undesirable data in the architecture that you just proposed?
So for fraud, we are managing based on the IP, I guess. That's what I remember. I'm not in retail as well. I'm working in some different domain, but the fraud analytics kind of, we are also identifying a fraud users basically. In an same case, fraud user can be in any industry, right? So fraud users right now, what we are doing, we are identifying using IPs, like one IP is used by multiple people, multiple users came in. In that case, we have flagged them, and there is different manual process done by somebody else in like compliance department, and they identify and we remove the record.
No, my question is around like, how do we perform validation on the data? We are just simply inserting the data into Kafka queue, right? So does consumers responsible for doing validations, or how do you do that?
I don't think so. Consumer is responsible, correct? Because I can go back and register any product, I guess.
I would like to answer this question. Like you're asking about validating the data. So the put API, put service, which will be writing the data to the Redis, before that it can be validated. And it can just simply return the error messages to the user, whosoever is updating the information or updating the product details.
Exactly, yeah. There should be definitely some kind of validation before accepting this data. Yeah.
So will that validation will be at the cache level, right? At the Redis, right? Or there is some mechanism itself.
It should be, because if you say that your request is accepted, then user assumes that everything is good with their request, right? So it should be done even before saving the data or inserting the data into the Kafka. But I'm just asking the question out loud, because since somebody is already using Kafka, I'm trying to see how they are doing the validations.
I think that the validation should be at the point where we can return the response to the user that it has been failed. So it should be before insertion to the Kafka.
Exactly, yeah.
So in Kafka, can multiple consumers subscribe to the same topic, or like each topic should have individual consumer? And secondly, if the consumer goes down, so how will will the Kafka push data to the consumer when the consumer comes up, or like how will the consumer know like from which point it has to again consume the data? Right? Does Kafka maintain some sort of offset or what?
Yeah, that's right. Actually, that's Kafka maintain all the offset based on the consumer. So one topic can consume by multiple consumer, and each consumer have unique ID.
Okay, yeah.
Just to confirm one thing, like, can we push all those like images and videos to Kafka? And if yes, then what would be the format? Like, will that be in binaries or it could be like something else?
Yeah, that's a good question. That's a good question I would like to ask. Because when I was during the interview, the follow-up is about the images. How do I store the image? And then the second follow-up is, what if the content contains like multiple images? And my answer was yes, same as someone who wrote down the doc, to store it in the S3 bucket. And the weird thing is, he asked me, what does a S3 URL looks like? I was like, what kind of question like that? But I still answer it like the HTTP request URL starting with s3.aws.com or something. But I'm not sure if that's a quite answer for it. But I do think it's still a weird question anyway. Yeah, keep saying.
Yeah, so image can persist in S3, but I'm not sure about the Kafka. Yeah. Go ahead.
Yeah, Kafka is primarily a distributed messaging service. I mean, the payload is supposed to be small, and I mean, it's designed to sort of ingest data at a really high volume very quickly and also consume very quickly, right? So I mean, images doesn't make sense. Also, Kafka shouldn't be used as a long-term persistent store. I mean, it is meant to be ephemeral, right? So if you really want to store some data somewhere, then you have to use a database. All the topics usually have a lifetime. The retention period, like be it, you can set it. And if you say like, I want to retain it for 3 days, for topics that are really heavy, your retention periods are small. But the idea is the consumer is going to consume within that period. Right. So yeah, I think images and all that stuff won't make sense. I mean, we mostly use it for like, if you want to build event-driven microservices and sort of, distribute messages across different components, you can use Kafka. I mean, you can keep other stuff too, but images doesn't make sense.
Okay, so in that case, like we'll be ingesting to Kafka like S3 URLs, and probably at the CDN side, they have to download it from S3 and put it at CDN. That's what we're proposing here. I mean, since we have to like push images or videos to the CDN itself. So what are we like? What information we are putting to Kafka? I mean, will that
I think insertion of S3 locators make more sense.
Okay, and it's CDN responsibility to download from those S3 buckets and enrich their data at their end.
I think so. It should be the case, but others can confirm as well.
What's the role of Redis in this case? I mean, the one that was in the beginning.
Redis is for your caching it, right? I mean, let's say in case your client goes down, then I think Kafka can get it directly from the cache itself, right?
I mean, who was putting? I mean, is it the? I mean, I just missed the initial part, so I was just wondering, like, what role is it playing for the read or write?
I had same question. So somebody said, who proposed this will investigate why they are doing it that way, and they will get back to us.
Sorry, I was talking on the mute. Actually, we are using Redis as a write store, and then Kafka is a listener to the Redis.
And why not directly write to Kafka?
That's something I have in my list to find out. We already covered that. I need to find out why Redis.
So you mentioned like if Kafka goes down, right? Then in that case, what will happen? I mean,
yeah,
you just mentioned.
Yeah. Right. So we can reprocess using the write tool.
Exactly. Just about the SOP, right? Single point of failure in this case, kind of.
I mean, Kafka doesn't go down since that itself is a distributed system. So potentially it can't go down altogether unless it is just a single node cluster.
Also, the data access pattern is different, right? I mean, Redis is a key value store. Kafka is like a
continuous stream of messages that you're going to
Yeah.
push in. So I was just trying to understand how would you even sort of, how are you either building the state between the two, or what is the relationship? I mean, you use Kafka mostly for streaming applications, and you would, on the other end for the consumer, you would put either a streaming connector or something, and then,
Yeah, we are using that streaming connector as a Kafka Connect. We are using heavily.
So somebody also asked this question. In Kafka, are the consumers pull-based, or will the Kafka push the data?
They are pull-based.
Pull-based.
Yeah.
Yeah, so Kafka clients will send a fetch request based on the Kafka protocol, and yeah, they sort of, you specify how much you want to prefetch, and those many messages will be kept in the client, and then you can sort of, your application can start draining them.
And as I mentioned in Kafka Connect server, which we are using, correct, there are two parameters we are managing. It's already inbuilt and pre-configured, like buffer time and buffer size. So you can configure both the parameters.
Correct.
So whenever that benchmark hits, correct, it spit out the data from Kafka to like target system, whatever it is. Like it may be Redshift or S3, whatever.
So what's buffer time? So is it like something like a TTL? Once it expires, it will push the whole data.
Yes, right. So you say like every 15 minutes, I need data. So that way, every 15 minutes, it's get out the data. If your buffer size is not hit, so either one of them hit, it will spit out all the data basically.
So you are doing just a batching to save the bandwidth.
Right.
Hi, I have a question. So can it be possible to consume the same message from multiple consumer in Kafka?
Yes, it is, but those consumers has to belong to different consumer groups, it seems.
Okay.
Yep.
So without Zookeeper in the latest versions, does anyone know how Kafka remembers like which offsets these consumers are reading from?
So the way, even with Zookeeper, I mean, the most recent ones, not the most recent, but a little bit older ones, they use topics for even for storing consumer offset. So if you dump the topics, like list all the topics, so creating a simple Kafka instance is super easy. You can just download the gzip and create a small cluster of 3 instances running on your machine, right? And if you create a test topic, if you consume, and if you dump all the topics, you will see __ consumer offset something number, right? So they just use the topic itself, another topic, like a internal bookkeeping topic.
Okay. So in the topic, they have all consumer group details along with consumers offsets.
Yeah.
From each partition.
I don't know the exact mechanism of the data, how they put in. There will be, I mean, I've seen a bunch of __ consumer offsets with a suffix, and I don't know what that suffix really means. Haven't dug that up, but yeah.
So does it perform linear scan to find, like to map consumer to?
So these could be potentially compact topics. So Kafka has a concept of compact topics where it can sort of mimic your key value store, where it will just keep the the most recent value or the last known value of a particular message key and its value. So there is you can keep sort of sending messages. Let's say for key 5, you send a message and you update it every minute. And if it's a compact topic, then it will sort of purge the old values and just keep the most up to date. When you consume, you'll just get the most recent. So these offsets, the consumer offsets, will probably be a compact topic, and then it can do a linear scan. It can sort of rehydrate the whole thing. It shouldn't be that big.
Okay.
So since this question has get and put method, I mean, it was to define. So was it related to sorting system or was it a storage system? Because,
I think it's more like a storage system. Yeah.
Okay. But okay, yeah. So if it was a storage system, then why do we need availability in this case, right? Does it make sense to have system to be highly available in this case? Had it been
you
used,
don't want to lose anything, right?
So
That's
yeah,
writing.
yeah, true. Suppose you are a seller, okay, and you are putting some info, and your info does not get to database, it gets lost. It's not what you want, right?
Yeah, if the system is not available, it's not a good user experience.
Yeah.
so, but it won't deal with the customers, right? This storage system won't be exposed to the customer.
But your sellers are also customers, right? Like for Amazon, they are customers. The ones who are putting the data.
Yeah. Really,
So
because they are making the business, right?
So their consistency makes more sense over availability, no? Let's say user posted three products.
Consistency will be for the people who are reading. So these guys, when they are writing, the system should be highly available so they can throw the data inside the system, and then the system takes care of everything. And the people who are reading, if it's for them, it's eventual consistency, it's fine, right? The seller, whenever he updates, the guy who is going to read, if the data is available after some time, that's okay, isn't it? For you, I am selling something and you don't get my item immediately, you get up to some time, that should be okay, isn't it?
I mean,
Yeah.
Yes. But system should be available to register the products. Yeah. Makes sense.
I think we are mixing two concepts here. One, durability and availability. Durability of the storage would ensure that your data doesn't get lost. Availability will ensure that whenever seller wants to upload any photo or something or any catalog, the system is available for them to make those requests. It doesn't return something like system is not available, it is down for maintenance, right? So availability will ensure that it is almost always available for the seller to upload their items. It doesn't guarantee durability. Durability is guaranteed when you have replication and all those things, right?
In case if you miss from one, you can get it from the other replicas. But okay, then here durability should be high, right? In this.
I mean, all of the characteristics should be high, but we can't achieve highly consistent and highly available. So we got to compromise on either of those
factors. No, but you see, if the site is not available for some time for the seller, it's okay. But if he has registered something and if that is lost, that is not durable, that's more harmful, right?
Yes,
then
once you say that you accepted the request, you can't lose it. So if you lost it, then your system is not reliable and not durable. So that is like definitely default characteristics that we need to have in the system. But what I'm proposing is you can't have a system which is definitely consistent, 100% consistent and 100% available. So that's not possible.
Right, but durability doesn't need to be compromised on.
Yeah,
your system can be highly available and durable at the same time.
Yes, that need not be compromised. So that actually needs to be a primary characteristic. And I mean, when you save something to the DB, it should not be lost, right? If you are purchasing something today and if you log back in after an hour, it can't say that you did not purchase anything. So that data should not be lost. There is no compromise on that.
The data should not be lost, but you can, as a system, agree on whether this data, I'm putting some data, right? Read after write kind of pattern, where I put something into the store and I immediately read it.
Right.
There can be some compromise based on the consistency characteristics of the system.
Yeah, then that is not available, but it is durable because data is still there. It did not.
No, it doesn't mean it has nothing to do with availability. It has to do with consistency. If you're not, so there are three concepts: availability, consistency, and durability, right? So you will have to compromise between availability and consistency. That doesn't mean that you will necessarily have a very badly consistent system. You can have some guarantees around query patterns. But yeah, I think we are on the same page here. I'm just trying to make sure that these three concepts are not mixed
Right.
together.
Durability is completely out of the picture, because when we speak of consistency and availability, it's not even like, I mean, basically these three are not related, but consistency and availability is definitely related. But what you are saying is, I believe it's on the same lines. If you update something, if you make a perform an update on some record, you can not have immediate availability on that record until all the replicas are propagated with that update. So you can either choose, eventual consistency with high availability, or if you're going for strong consistency, then you should say, maybe update is progress.
I think you're overloading the word availability there, right? I mean, availability has nothing to do. It's whether a system is available or not. Can you process requests or not, right?
No. When I say availability, let's say I perform an update right now on some product data, then immediately I logged in to read that update. The data is stored in the system, but system is not showing me the data because the data did not get propagated to all the read replicas.
That's consistency.
Right.
That's not
That's a consistency. Yeah, that's a consistency, right?
Yes, still. So basically, let's say now I don't want to have a strong consistency in my system. When I log back in, immediately the system will show me something, whether it could be an updated data or whether it could be a stale data. Then I had a strong availability, great availability, but I did not have strong consistency here, because the data which I'm showing to the user may or may not be updated one.
So you're talking about the trade-offs. I mean, you can do some trade-off between the two.
Yes. So when that's what I'm talking about, is like whether we could have highly available and or highly consistent, but not both of them.
Even in your case, Harsha, there is a way to be to exhibit better consistency than what you are proposing, right? Some seller uploads their data, and you're saying you are reading just after writing, right? Even that kind of consistency can be ensured. What you can not ensure is some other seller trying to see this data from other sellers get, right? What the way you want to partition your data is that all your write and all your put and get requests go to the same shard, go to the same partition, go to the same Kafka topic. I mean, not topic, but the partition inside the topic. If you make sure all of these things, then it's highly likely that you will be able to read your writes.
So high availability and consistency is definitely possible, right? I mean, just going by the theory, right, of the cap. So you have to trade off one of them, not. You can do the.
So when we speak of distributed systems, you can't achieve availability and consistency at 100% capacity. There is definitely some optimization that we could do.
No, why not?
Why not means, so when you speak of distributed systems, right? These distributed systems are.
What is? I mean, just a definition of consistency is if you read from any node, you see the same value for that particular request that you're sending.
Right.
So ideally, if you can achieve that in a distributed system, then you're strongly consistent, right? And
True. So
consistency has like
the network partition doesn't happen, right?
Right.
So I feel this is a rabbit hole. Consistency has like 10 definitions. What you cannot achieve according to the cap theorem is something like serializable consistency. You can easily achieve read after write consistency. So there are 10 different variations of consistency. You can have high availability, a very nice level of consistency. Let's put it this way, and but other things like partition tolerance and all those things. What you cannot achieve is the strongest form of consistency, which is like serializability, linearizability, right? So
I mean,
I feel like let's not get into this rabbit hole.
No, I mean,
hey, according to cap theorem, we say that a system can be strongly consistent and strongly available, right? Is there an example of that? I think that a system can, if it's highly available, it can be eventually consistent, or it can have good consistency, but it can't have 100% consistency, right? Is that true?
All the banking applications, they are highly available as well as highly consistent, right?
But they are not necessarily highly available, right?
Most of the times it's available. Very,
banking systems mostly use RDBMS, right? We can't really say that it's going to be highly available.
So CAP theorem is slightly misleading. The right construct for the CAP theorem is CAP theorem stands for consistency, availability, partition tolerance. And the usual way to say is choose any two. But you cannot control partition tolerance. Basically partition in the system, in a distributed system.
Exactly,
So the correct way to represent is given partition in the system, either choose consistency or availability.
Right.
So
when you
are right. Whoever was saying that you cannot have a strongly consistent and strongly available system, but then you will have to guarantee that it never partitions, which is not true for distributed.
So what I mean to say is when you have a single node, you could definitely have availability and consistency together because all the writes and reads go through the same single node. But you did not have partition at all there. Like there is no network partition.
No,
but if that single node goes down, we can't really have high availability there, right?
So, but then what
you can, as long as you have failovers and other replicas. I mean, like
if the single node goes down, then your assumption is wrong, right? You are creating partition in the system.
We are using distributed system because we want to have multiple nodes. If it's a single node system, we can't really say that it will have high availability.
No, it is highly available as long as it doesn't go down. And if it goes down, it means there is a partition in the system. So,
I mean, we can't really guarantee that, right? That single node won't ever go down.
There is no point in discussing this, right? There will always be a partition. So you either choose a consistency or availability.
Right. Yeah, that's what I mean to say as a summary. Yeah. As per the Venn diagram, basically you can't choose 100% of consistency and 100% of availability is what I mean to say when you have a partition in place in the distributed world.
So I have a question. I have a question like if the data is not 100% consistent, or let us say we are accepting some lag in consistency, in that case, if there is some product which we are adding and it has an attribute SKU which is unique, so how that uniqueness is checked if the data is not consistent?
Why would that be a problem? I'm not understanding quite right. Maybe, yeah, keep going.
Am I clear on my question?
Can you repeat the question once?
Yeah, the question is that let us assume we are adding products and SKU is unique. Two products cannot have the same SKU. And we accept that we are accepting some lag in the consistency as per the CAP theorem. Even in that lag, if two products are added with the same SKU, how we are going to handle it? How we are going to validate that no two products can have the same SKU?
What's SKU actually? Is it a primary key?
Yeah, it's a primary key.
It's a unique constraint on the product. Let's say that it's a unique constraint on the product table. Okay? We are saying that SKU is a unique constraint and we want to add two products and we want to check that every new product should have a unique SKU, right? How will we guarantee that if it's an eventual consistent system?
Yeah.
It will be guaranteed by the main database itself, right?
What's the main database? If it's a distributed database, if it's a multi-write database, then
it probably be the master and slave database architecture, probably.
Is this Q value coming from the end user? So basically it's not system generated and somebody is entering, let's say ID1, and the same ID1 should not be inserted into the DB by another user, right?
Correct, yeah.
Yeah.
I think this master distributed system won't work here. We'll have to have a single write node and multiple read replicas. For this particular use case, I think multi-write distributed database won't be a good choice.
Also, in such use cases, we shouldn't use user entered thing as a primary key.
Yeah, I think it's just an example, like to see how we handle same kind of values coming into the system at a given instant of time.
It's a unique constraint, not really a primary key, but yeah.
I have a question. So in this, so if the SQ is that important, then why don't we go for a strong consistency? I mean, we can trade off the availability to get the consistency in this case. Because to me, it feels like that SQ is actually important, right?
Yes, I agree. I think we'll have to use strong consistency in this case. We can't really have eventual consistent system. We want to have a unique constraint for some column.
But here our goal is to make system highly available, right?
Yeah, I think that's the trade-off we are talking about. The system can't really be highly available if we want to have consistency on a specific column there, right?
Yeah. So if you think of all social media websites, LinkedIn, Facebook, and all these things, they are highly available because of eventual consistency. I mean, slowly you will get the updates which your friends or colleagues are making, but basically the data will not be like strong, consistent.
Yeah, I agree, because I find some like special things when I using the LinkedIn. For example, if you are sending a connection request to someone, and then he agreed to connect, but when you open the chat box, there you will see latency because there's still an option to connect with him, but you guys already connected and you're chatting with each other, but you do see there's a plus connect options.
Yeah. The reason being, when you refreshed, it might connect to different read replica, and the data might not be propagated to that replica yet. So that's why you see that discrepancies. So basically, you lost consistent behavior, but you definitely had available. It's not saying that, oh, now the site is down, please come back after some time, or maybe wait for some time to data to get replicated.
Yes, exactly. And another thing I found is when you check your networks page, and you will see, for example, you have your new connection being added to the page, but there's a number that shows how many connections you have. The number is still the same like before. It doesn't plus the new one into the number or index. So I think it comes with another server maybe.
Yeah, regarding the SQID, I think, what happens whenever you want to enter any seller tries to enter any details. So whenever you put a SQID first, that is validated. The system validates that. And even though if two sellers have the same SQID and they concurrently enter the same data at the same time, so that concurrency issue should be handled. So one of the sellers should be notified that his data is not entered. So that is one way of doing it.
So that is possible only when we have single system which acts as a administrator who can tell us whether that is a valid ID or not.
Well, that SQID is done by some central service.
Yeah,
it
exactly.
actually tries to validate that. And that because when you are entering all the details, it's based on that SQID. It acts like a primary key, it's a sort of primary key, but it is it has to be unique for that same product, throughout the whole system. So if you are trying to, another seller is trying to enter another data with the same SQID, it means that he's trying to sell another item for the same SQID. So that is still fine, right? So in Amazon, you can see there are so many sellers who are selling the same item. So that should be okay. So he's going to sell under the same SQID. But
I think that was not the right
is...
example. So probably a better question is, let's say we want to have a unique constraint for some column in a table, right? Can we achieve high availability in that case?
So what example you want?
Yeah,
So let's
you
say,
can. It's very easy to achieve high availability in that case.
let me give a better example, right? So let's say there is a user service where every user is uniquely identified by their email ID, right? Now, a user one has already created, signed up with an email, and let's say that is not propagated to all the nodes. And then another user comes, and then he also wants to sign up with the same email ID. Can we achieve a highly available system in that case?
Well, first of all, why is two different users will have same email ID?
He again, I mean, another user is trying to sign up with the same email ID, right? There can be a case, right? You try to sign up again with the same email.
Okay.
We should say that this email already exists in the system.
Yeah, see, highly available in the sense you can accept the request, okay, because you're writing, but somewhere it has to be validated, right? So
how do we validate that in if we want to have a distributed database?
So before you are entering into your persistent storage, there has to be some validation to be done, isn't it? So the first user actually whoever has written it and has written successfully, then the other either if it is conflicting with that, so that conflict management has to be done. So conflict resolution has to be done. So either you do a conflict resolution automatically, or maybe you send a manual conflict resolution for the second user or the first user either. So it depends on how your system is going to be designed. And that is what I'm thinking. I'm just thinking loud. I don't know about it.
I think maybe let me explain that question again. So user one comes up with his email ID and signs up. This email ID, let's say there are 5 nodes in the system. This email ID has been propagated to 2 nodes, and then another user comes and he also wants to sign up with the same email ID. Now, when we are checking for that email,
when you are saying it propagates to 2 nodes, those are the read replicas, right?
Those are the write replicas. Let's say quorum is 2, right?
So those then the quorum will be 2 based on if your whole quorum is not satisfied, then you are not going to return back to the first user also, right? So that's not going to be same thing, right? So you have to satisfy the quorum, no? So then it's not so it means the first user has not been completely satisfied. His request is not satisfied.
But you are talking about strict quorum, Santosh. There can be
so then you have sloppy quorum. For that you will have a different way to do it. So the way the sloppy quorum does, I'm not aware of it how it does.
So I mean, we can't really
surely some way to do it, isn't it? It's not like this is something new. It has been, everyone has been doing it. Yeah.
Okay.
I don't know. Basically, what I'm saying is, if it's a sloppy quorum, how it's handled, but it is being handled some way. We'll have to look in that details.
A lot of times you will have application logic to enforce it in sloppy quorum kind of things. But yeah, agree with Santosh. It's how you do it. I mean, especially when you're talking about 5 replicas, right? What is the system you're talking about? Like 5 replicas of what? Is it a relational database? Like MySQL can have 5 replicas. Is it a Dynamo?
Think about Cassandra maybe, right? It has 5
it is Cassandra,
nodes.
right?
Yeah.
You can have constraints on your key, but you're saying there's a distributed key. So what is your write quorum, right? Read plus write should be greater than the majority of the nodes, right? If you have that, then you will likely be able to find out that there is a violation of the constraint. If you
okay, yeah, that makes sense. Yeah,
W plus R is greater than the majority of the nodes. Right?
Okay, that was the answer. Yeah, right. That's what must be done.
Yeah, that's good. Yeah, thanks. Okay, so any more questions for this session, Alex? Do you have any questions?
I think I don't have much questions. I would like to ask, like, who is the anonymous folks who writing the notes here? I think it's a very good summary. Was that you, Shashank?
Yeah. Alex, Alpesh, he will write it, right? Whatever the architecture he has proposed, and
yeah, So probably I can post it today or mostly by tomorrow. And also I wrote a couple of questions like why each component is responsible and what is the role it's performing. Like W questions for most of them. Probably I'll draft it. Just give me 1 or 2 days. I'll do it.
Sure. That will be great helpful, Yeah. Please
Also,
post that.
Alpesh, if it will be very helpful if you add the get service infrastructure as well.
Yeah, definitely. I'm just gonna draw in draw.io so that everyone can visualize it.
And it would be better if you take one session on Kafka 1 or 2, so because you are already working with this system, right? So you might be having the exhaustive. I mean, like
yeah, definitely. I'll take some session.
Well, thank you so much. I do think today's session is really helpful. I believe if you guys were there, you must got a strong hire. I do hope we can have more like interview question review sessions like this, or someone would like to do like mock interview and everybody can like get feedbacks immediately from experienced engineers as you guys. Well, that will helpful.
Yeah. So in my interview in Amazon, they asked me about the Amazon search. Like when you search in search bar in Amazon.com, correct? When you say star, so your drop down comes with the star initials, correct? Like Star Troop, Star Wars, whatever star, correct? Okay. So I designed that system in my interview. And it went really well that day. And maybe that day is mine. So interview didn't have any other question for me.
Okay.
That's cool. Yeah.
Alpesh, can you take one session how you come up with the solution on the
Oh, yeah, definitely. I need to recall. I took interview around 3-4 years back, but I know architecture, how does I design everything. And okay. He had a lot of questions, like Alex said, he just went down in each and every component.
Okay, probably if you have time in the upcoming week.
Yeah, definitely. Just keep remind me because
maybe
now,
next Friday we can think about it, right?
Yeah, that way is better because I work in different role in different company and I have tons of thing to do. So I'm really lazy kind of thing in this kind of stuff. But this one I wanted to finish today. Today is Friday and I took my half day. So I thought let's finish today. That's the reason I asked Shashank to arrange this session.
Cool.
Well, that will be great.
Yeah.